Hello everybody, also from my side. My name is Sigmar Bootsch and I'm employed in the headquarters of WOMA here in Duisburg. I've been working in various positions in the high pressure business for about 22 years, and now I belong to the department WOMA Academy and Application Technology. The main topic of this webinar is ultra high pressure pumps, also called UHP pumps. In the next about 20 minutes, I will explain some terms and definitions to you and give you a first short introduction in the UHP world. The aim of this webinar and presentation is really only to give you basic information about how high pressure pumps and high pressure systems work. First of all, what is high pressure? High pressure, you can use also ultra high power. Everyone knows pressure is a force on an area, and we use different dimensions like bar, psi, or kilopascal. To give you some examples, how high is the pressure in our real life, here's some examples. And you create about 0.2 bar on the surface under your shoe. The ladies have a little bit more pressure, so the high heels create about 120 bar, and the highest pressure on Earth you find the Mariana Trench in the Pacific Ocean, about 1,100 bar. The main performance based only on mechanical parameters of the high pressure systems. First, we have the pressure, but we have to look also on the flow rate. This is very important. So the combination of pressure and flow rate creates a performance you see on the surface. Give you some typical pumps you find on the market. First of all, centrifugal pump. That means you have here a cheap design. We have only few rotating parts, a very easy sealing, but these pumps are also limited in pressure. Advantage of this pump is extremely high volume you can create with it, but the biggest disadvantage is the low efficiency of this pump type. Another pump type you find as a typical pressure washers. It's a bobble plate pump. It's also a fast running pump, and you find here a cheap design. These pumps are also limited in pressure, and you find this always in systems, high pressure systems below 15 kilowatt. But these pumps are no UHP pumps. When we speak about UHP pumps, we always speak about plunger pumps. That means we have an oscillating pump with a complex design. You find here a very high-tech sealing system, and we use mostly a crankshaft drive. The UHP pumps are slow-running pumps. The biggest advantage is the high efficiency of the pump. So it goes up to 96%. So when you put 100 kilowatt on the crankshaft or the drive shaft, you get about 96% on the outlet of the high pressure pump. The main components of a high pressure pump is a power end where you fix the engine, the drive engine, and this part, the power end, is an oily part. In front of the pump you have the pump head, and between the power and the pump head you have the lantern where you find the plunger and the sealing system. Let's have a look on the schematic diagram of a plunger pump. So we have the drive shaft, which drives the crankshaft, and the piston rod creates the rotational motion of the crankshaft in a linear oscillating motion of the piston. In front is fixed the lantern, and here you find the plunger, which is connected to the piston, and in front you have the pump head. Let's have a look on the pump head and how it works. We have the plunger with a sealing system and the pump area with a water inlet connection and a inlet valve, and high pressure outlet with a high pressure valve. So now, how does this work? When the plunger moves backwards, water goes inside the pump head, and when the plunger moves forward, the inlet valve closes and the high pressure outlet opens because of the higher pressure in the pump head, and the water can go through the nozzle and you can use it as a high pressure jet. So this is a normal function of a pump head. In this case, in this example, you see a vertical arrangement. It could be also a horizontal arrangement of the pump head. 95% of the high pressure pumps are 3 plunger pumps. That means when the plunger goes forward and backwards, we have a peak, a maximum pressure at, on the first plunger, and goes back to the minimum pressure. That means 0 pressure. The second plunger is offset by 120 degrees. And the same with the third plunger. That means we have in total average pressure. So we have here a pulsation, what you can find or what you can feel also on the high pressure hose. So that means the pressure and the volume is not 100% linear. So we have this pulsation and peaks, and this is due to the multi-plunger pumps. The pump speed means we have a slow running pump due to the crankshaft design, the handling of the heavy rotating parts and masses, and high loads in the high pressure pumps. So the UHP pumps are designed for pressing water and not for sucking. That means we have a maximum speed limit because of the cavitation what you can get during the suction stroke of the plunger. So the average UHP pump speed is about 250 and 500 RPM on the crankshaft. But we have also a minimum speed limit due to lubrication. So we need the lubrication of the crankshaft bearings and the crossheads inside the power end. In case of extreme low RPM of the crankshaft, we can use also additional oil pumps to lubricate the crankshaft bearings and the crossheads. To drive a high pressure system, we can use an electric drive. That means we have a fixed speed of 1500 RPM at 50 Hertz and 1800 RPM at 60 Hertz. Or we can use diesel driven systems. Here we have engine speed of 1800 RPM. Now, we have here a range of 1500 RPM to 1800 RPM. On the other side, on the drive side, and on the pump side, we want to achieve a crankshaft speed about 250 to 500 RPM. There are also pumps which have a higher crankshaft speed, but 95% they use lower speed. How can we achieve this? First of all, we can use, for example, pulley drive with fixed ratio to get on this lower speed, or we can use pumps with internal reduction gears. So here we have also fixed ratios. When you speak about high pressure, you speak always of the pressure which is measured direct on the pump head. But we have in every system pressure loss. That means the pressure on the pump head is higher than the pressure you find at the outlet of the water tool, of the nozzle. So in each component you use in the system, you have pressure loss. That means in the hose lines, in the couplings, for example, in the gun or other water tools, and that means the pressure on the nozzle is always less than on the pump head, and this you have to look on. So when you use components with a bigger inside diameter, you have low water speed, and with this you can reduce the pressure loss. And we have to optimize the pumps and also the water tools to minimize the pressure loss in the system. For example, pressure loss in hose lines. A typical example for service contractors. We want to use 2,800 bar with a flow rate of the pump of 20 liters per minute, and it's a typical application to you have to use 100-meter hose lines from the pump to the water tool or to the place you want to remove something. So, for example, when you choose a hose line of inner diameter 5 millimeter, find here a chart where you see the flow rate of the pump and different lines with different diameter of hoses, and you can see here the pressure loss per meter. In this example, first example, we have 20 liters per minute flow rate, hose line of inner diameter 5 millimeter. So you find here a pressure loss of 6 bar per meter. So in this example, you have pressure loss of 600 bar only in the hose lines. The same example with the same pump, and you choose DN10, inner diameter 10, you have 20 liters per minute to the line DN10, and you find here a pressure loss of 0.2 bar. That means in the second example, you have only a pressure loss of 20 bar per meter. So, and this is only the pressure loss in the hose lines, plus couplings, water tools, and so on. So pressure loss is a thing you have to look on. So without a nozzle, you can't create pressure. When you have a big opening at the high pressure pump, you have nearly no pressure. So you need a nozzle. So the nozzle squeezes the volume which is created by the pump through a small opening, and this creates pressure. That means the flow rate goes through the small opening, and then we have the pressure. So on the side from the nozzle, or between the nozzle and the high pressure pump, you have a low speed and high pressure in the system. And when the jet gets out of the nozzle, we have a very high speed and low pressure. So the potential energy is converted in the nozzle into kinetic energy of the high-speed water jet. The nozzle means as a zone of energy transformation. Only if you choose the proper nozzle to the pump performance, you can create or convert the complete energy from high pressure in the jet. So nozzle is an energy converter and converts pressure into speed. Everybody wants to regulate pressure, to adjust pressure, but how can you do it? You can use only two possibilities. First of all, adjust the volume, means you can adjust the speed of the pump, or you can put a part of the volume in a bypass. The second possibility is to adjust the nozzle diameter. That means you can use a second or open a second nozzle, or you can exchange the nozzle, then you can adjust also the pressure. So these are the only two possibilities how you can regulate the pressure in a system. Very important thing for the operator is the reaction force. So you have the jet which gets out of the nozzle. That means this jet creates a reaction force. And the reaction force should be minimized for manual operator. The maximum allowed reaction force on a handhold tool with shoulder support is 250 Newton. Without shoulder support is 150 Newton, means 15 kilograms. The reaction force, what is very important, is linear to the volume, but to the pressure only under the square root. So the volume is more effective on the reaction force. I think everybody knows this also in different films. We have here pressure about only 10 bar, but the flow rate is very high. So important summary, volume makes the power of reaction force and not the pressure. So far, thank you for your attention and see you in the question part. Thanks.
Hello everybody, my name is Hans Borgt. Besides my function as president of the EWJI, I also work at the Dow Chemical Company. I will lead you in the second part of this presentation, and this is more about what we are doing within the working group high pressure pumps over the EWJI. What is the working group for pumps? It's a group of people out of industry that represents the manufacturers and OEMs of equipment, the users, so the service providers, safety associations, and end users, asset owners like, for example, my company, working together to create a better understanding of the requirements concerning high pressure pumps. Are there standards, technical requirements and guidelines? The simple answer is yes, there are. But which ones are the question? I would like to challenge everybody who is online at the moment to use the chat function and just enter the ones you think that apply for high pressure pumps. I'll give you some time. I hope somebody will enter. If not, then I'm going to continue. You will have time till the question time, then I want just to discuss some of those. How can you get involved in the working group? We would like to ask anybody who's interested to help the industry to progress to come forward and join us. The working groups are open to members of the EWJI, but also to non-members. What is the CENTC 197 working group and how is EWJI connected? We will notice during the questions and answer time that there are different European guidelines and regulations already available for high pressure pumps and high pressure equipment. Those requirements are being maintained by technical committees. One of those technical committees within the European Committee for Standardization is the TC 197. This technical committee discusses everything in regard to high pressure pumps. EWJI is in the process of becoming part of the CEN TC 197. So there will be discussion about our application within about a week, and then we will try to inform everybody about the outcome of that process. But what the technical committee really does is maintain the standards, requirements. So what they do is they review them, they update them, and every 5 years they bring out a new version. Most of the time there are only small adjustments, but one of the things, and we will see that later in this presentation, is that sometimes there's some contradiction within different standards and requirements, and one of the things we want to do is to help the industry to streamline those. So, the working group high pressure pumps. The rules and expectations regarding high pressure pumps should be unambiguous. They aren't at the moment, like I just mentioned. To achieve that, we have some end goals, some short-term goals, and some long-term goals. If I start with our end goals is to have a clear and unambiguous expectation and rules for high pressure pumps. How do we want to create that? To have a publication that explains expectations and informs about high pressure pumps. To assist in the creation and updating of European requirements towards high pressure pumps, like I said, through the CEN TC 197, and to promote European regulations and reference documents on high pressure pumps, use and requirements to improve safety, processes, and ensure quality. How are we going to get there? Like I said, one of the items is to have a publication that explains expectations and informs about high pressure pumps. The guidelines and requirements have to be agreed on to make sure that all requirements in the European area are aligned to each other. The EWJI will support national safety associations, manufacturers, end users, and also users, so the contractor companies, to achieve that goal. To assist in the creation and updating of the European requirements towards high pressure pumps. Like I mentioned, the EWJI is on its way to participate in the CEN TC 197. This commission maintains the different European standards and requirements to all equipment and tools linked to the ultra high pressure pumps and water jetting. To promote European regulations and reference documents on high pressure pumps, use and requirements to improve the safety, processes, and ensure quality. Make contractors, asset owners, and suppliers, manufacturers aware of prevailing regulations and latest techniques about safety, efficiency, quality, and productivity. Our short-term goals. Identify all relevant guidelines in Europe and outside of Europe. Join the CEN TC 197 working group. Identify inconsistency in the guidelines and try to address these. Identify the need for our members and the broader industry. Work on proposals towards current requirements. Our long-term goals is, like I said, have clear and unambiguous expectation and rules for high pressure pumps. To promote global regulations, first of course European, later on the global regulations, and reference documents on high pressure pumps, use and requirements to improve the safety, processes, and ensure quality. Thank you.